Hi class, this week we are going to discuss multiplying polynomials. Last week our focus was on classifying, adding, and subtracting, and I'm going to start out this week multiplying a monomial times a polynomial. So hopefully from last week you remember that mono indicates that we have one term multiplied by many or four or more when we use the word polynomial. So the biggest rule that we have to remember is something from our chapter on exponents, and that is when you are multiplying two terms together that have the same base, we must add the exponents together. So essentially, we're trying to figure out how many x's there are, how many h's, how many k's. So if you look at number 1, you'll notice that there's a letter on the outside of the parentheses, and something we've done from early on in the year is distributing. So we're going to distribute this h to each term in the parentheses. So you have a monomial, one term, h, times a polynomial, many, h plus 4. So we multiply this h by each term in the parentheses, h times h. Remember there's a 1 with each of these. So when you add that, you end up with h to the second power. Plus h times 4 would leave us with 4h. Very similar in number 2. We're multiplying k times k. That will give us k to the second power. And k times a negative 9 gives us a negative 9k. Notice how I'm including that minus as a negative sign with the number 9. In number 3, we're multiplying 9a times 1a. So remember there's a 1 in front of this. We multiply those coefficients. 9 times 1 is 9, and there are two a's here, so that would leave us with a to the second power. Then you'll multiply 9a times 1, which would leave you with 9a. In number 4, you have 6p times p. That would be 6p to the second power. And 6p times negative 8 is negative 48p. You'll notice again I'm multiplying the coefficients, the numbers, and you include the variable, or if there's more than one, make sure you add them together. 3c times negative 2c would be negative 6c to the second power, and 3c times negative 5 is negative 15c. Continuing along in number 6, negative 4 times 2 is negative 8. Now here you have 2 plus 1g, so that would give you g to the third, and then negative 4g squared times 7 is negative 28, and you keep the g squared in your final answer. From 7 to 12, we're adding a few more terms in here. You have x times x squared. Well, there's 1x here plus 2x's. That gives you x to the third power. X times a negative x is negative x to the second power. And x times 3 is a positive 3x. Okay. In number 8, you have 5 times 3, that's 15, and then you'll add your m's together, so 2 plus 2 would give you m to the fourth. 5m squared times negative 1m leaves us with negative m to the third power. You have 2 plus 1 is where I got the 3. And last part, you will multiply 5 times negative 7, which would give you negative 35, and you keep the m squared the same. In number 9, you have negative 3n times n squared. That is negative 3n to the third. 1 plus 2 would give us 3. In this case, we have negative 3 times negative 2. Now make sure you have two negatives, so this turns into addition. You will be adding 6. And you have 1n plus another 1n would equal n to the second power. The last term you're multiplying negative 3n times 8, which is negative 24n. Okay, moving along through the notes, number 10, negative 2x times 6x squared is negative 12x to the third. Negative 2x times negative 12 would be positive 24x squared, and then negative 2x times 18 would give you a negative 36x. I think all of that should be pretty straightforward to you. You'll notice for 11 to 15, these problems have multiple variables in each term. So again, you only add the variables together that are the same letter. So in this case, you have 3xy times x squared. That would give us 3. Now there's 1x plus 2 x's. That would give us x to the third. There's no y to add to it, so y will stay the same. In the second term, 3xy times 1xy. That would leave us with 3x to the second, y to the second. And then in our last term, we'll multiply 3xy times y squared, which would give us 3x. 1y plus 2 would give us y to the third. In number 12, multiply 5 times negative 2. That would give us negative 10 r to the fourth, s to the second. Again, adding 2 r's with 2 r's there. 5 times 3 would give me 15, and then add your r's together, r to the third, add your s's, would leave us with s to the third. 5 times negative 4 is negative 20, r squared, and add the s's together, we would get s to the fourth. Okay, in the last row, 3 times 4 would be 12. Add your a's, a to the third, keep the b. Then 3 times negative 7 is negative 21. Bring down your a, add the b's together, you have b to the fourth. Number 14, negative 4 times 9 is negative 36, and then add the c's and d's together, leaving you with c to the fifth, d to the fourth. Negative 4 times negative 4 would be positive 16, c to the fourth, and d to the seventh. And the last one here, 10 times negative 2 is negative 20. Add 4 with the 1m, that gives us m to the fifth, and 1 plus 3 gives us n to the fourth. 10 times 3 would be 30. There's no m, so m to the fourth will stay the same. Add the n's together, you get n to the second power. That's the distributive property portion of this assignment. Now, if you look at the bottom, you will notice that there is 2 steps here. It says distribute, then simplify the remaining expression. Final answer must be in standard form. So you're going to look for something that you can distribute first. In the first one here, number 16, we're going to distribute negative 2x. That will give us negative 6x to the second and positive 8x. Bring down any remaining portion of the expression. And now look at the terms you have left over. Start with the highest exponent, in this case negative 6x squared. There's no other x squared, so that will be the first term. And then add 8x and 7x together, resulting in a positive 15x. That would be your final answer for number 16. In number 17, you have 2 places where you need to distribute. So we will distribute 5w first. 5w times negative 7w is negative 35w to the second power. And then you have 5w times 3, which would be 15w. As you distribute the 2w, you'll have negative 4w to the third power. 2w times 19 would give you 38w to the second, and 2w times 2 would give you 4w. Again, look for your highest exponents and work your way down. So there is 1w to the third power. That will go first. Then you have w squared. Negative 35 and a positive 38 equals a positive 3. Notice when I am adding, though, the exponents do not change. We keep w squared. And then last but not least, you have to add the w's. So 15w plus 4w would give us 19w in our final answer. All right, I'm going to finish 18 and 19 here with you. If you want to give 20 and 21 a try, you are more than welcome to, and we'll see how you do on those two, but I would like you to finish through 19 at the least. Number 18, we will distribute the y, gives us y squared plus 4y. Distribute this negative y, gives you negative y squared plus 3y. And bring down negative 9y. You will notice you have a positive y squared and a negative y squared. They will cancel each other out, leaving us with 3 y terms to add together. 4 plus 3 is 7, and 7 minus 9 is negative 2y. Last but not least, number 19, we have 2 portions to distribute. We'll distribute 6x first, giving us 12x squared minus 18x. Then we'll distribute the negative 5, giving us negative 10x squared, negative 45x, and a positive 15. At this point, combine your like terms. You have 12x squared minus 10x squared. 12 minus 10 is 2. You have negative 18 and negative 45. That gives you negative 63x. And you have one constant term left over that you will bring into the final answer, plus 15. I encourage you to give 20 and 21 a try. We will continue with some more practice on this multiplying concept throughout the week, and we will continue talking about multiplying polynomials and wrapping up our unit on polynomials next week. As always, if you have questions, please let me know. Thanks.